Okay, hello everyone. So in this video, we're going to learn about exponents and scientific notation. And at the end of this video, we are expected to learn about the following. First is to define what are exponents. Second is to evaluate expressions which has positive, negative, and zero exponent. And lastly would be to rewrite or express very large number or very small numbers using the scientific notation. Now, what if we are given this kind of expression? 4 times 4 times 4 times 4 and times 4 again. Can you think of any other way to write this one in a simpler way? Actually, in mathematics, we can just simply write this one as 4 raised to 5, wherein 4 refers to the factor that we use to be multiplied to itself, while 5 refers to how many times we use 4 as a factor. So in this case, we use 4 to be multiplied to itself 5 times. Let's have another example. Let's say we have 3 times 3 times 3 and times 3 again. This one is actually can be written as 3 raised to 4, wherein 3 refers to the factor that we use, the same factor or the repeated factor, while 4 refers to how many times we use 3 as a factor. So in general, expressions with exponent is written in the form a raised to n, where a represents the base and n represents the exponent. And the n or the exponent tells us how many times we're going to use the base as a factor. Now, what if we are given an exponent which is negative? Let's say, for example, 5 raised to negative 2. Are we going to think that 5 will be multiplied negative 2 times? We will find out later as we go along to the discussion of negative and also zero exponent. So we're going to have or apply what we have learned a while ago, which is about the positive exponents. So let's have this table. Okay, in this table, we are given the following expressions. We have 10 raised to 3, 10 raised to 2, 10 raised to 1, 10 raised to 0, 10 raised to negative 1, and 10 raised to negative 2. Now, what we're going to do first is to expand or get the meaning of the following. So, we have first 10 raised to positive 3. And basically, this one is just the same as 10 times 10 and times 10 again. And its value is equal to 1,000. For 10 raised to 2, we have 10 times 10. And its value is 100. Since 10 times 10 is equal to 100. For 10 raised to 1, what we will be left is just simply 10. Since we just simply use 10 once. And its value is obviously 10 as well. Now, to get or to find out the value for 10 raised to 0, let's try to observe the pattern from the first 3 examples. Now, what if we multiply each of the following expressions by 1? Everything will be multiplied by 1. Will the values that we obtained change? Or will it be affected by multiplying it by 1? Of course not. The values will not change and it will not be affected even though we multiply it by 1. And it is because of the identity property and multiplication, which tells us that whenever we multiply any number by 1, we're still going to arrive with the number itself. Right? So in this scenario, in this case, if we will no longer use 10 as a factor since the exponent is 0, so what will be left in our expanded form is just simply 1. Does it make sense? Now let's take a look at the value. From 1000 going to 100, it was divided by 10. From 100 going to 10, as the exponent decreases, it was again divided by 10. So following the same pattern, 10 will be divided by 10 and that will result to 1. So therefore, 10 raised to 0 is just simply equal to 1. Or any number that we raise to 0, since we're not going to use that number anymore, so what will be left to us is just simply 1. Now let's continue this one. What about for 10 raised to negative 1? We mentioned a while ago that as the exponent decreases, it was just keep on being divided by 10. From 10 raised to 3, we have 3 copies of 10 here. Going to 10 raised to 2, having 2 copies of 10. Going to 10 raised to 1, having 1 copy of 10. So, the number of 10 is being decreases or it just being divided by 10. So, we will do the same thing going from 10 raised to 0 up to 10 raised to negative 1. So, in 10 raised to 0, we have 1. So, 1 now, to get 10 raised to negative 1, will be divided by 10. To follow the same idea. So, we will now have 1 over 10. And its value is simply 0.1. And connecting this to our observation a while ago, 1 divided by 10 is also equal to 0.1. Now let's continue. If 10 raised to negative 1 is being divided by 10 once, now this time for 10 raised to negative 2, we're going to divide again 1 by 10. So in 10 raised to negative 1 we divided it by 10. So this is 10 raised to negative 1. And since we are now in 10 raised to negative 2, so we will divide it by 10 twice. So we will have 10 times 10. And that will give us 1 over 100. Or simply 0.01. Now let's try to summarize how to evaluate expressions which has negative exponents through the following examples. For 10 raised to positive 1, we just simply have 10 here. While for 10 raised to negative 1, what we had a while ago is 1 divided by 10. And for 10 raised to positive 2, we have 10 times 10. While for 10 raised to negative 2, it is actually the same as 1 over 10 times 10. And if you will notice, there is something in common between the two expressions. 10 raised to negative 1 is just the same as 10 raised to 1 in a sense that, in this case, 10 raised to negative 1 become positive, or the negative 1 became positive, but now in the denominator part. Same goes with 10 raised to negative 2. 10 times 10 can be simplified as 10 raised to positive 2. Our negative exponent became now positive, but it is now in the denominator part. Same thing will happen if we have 10 raised to positive 3. 10 times 10 times 10. While for 10 raised to negative 3, that is actually 1 over 10 times 10 times 10, or simply 1 over 10 raised to positive 3. Okay, so to test your understanding on our lesson a while ago, let's have the following examples. Kindly pause the video for a while and try to answer the following before we proceed in checking these examples. Okay, so for number 1, we are given 8 raised to negative 3. And this one is also the same as 1 over 8 raised to positive 3. And 8 raised to positive 3 is also equal to 512. So your final answer here should be 1 over 512. For 4 raised to 5, since 4 times 4 times 4 times 4 and times 4 will give us 1024. So this one should be our answer. For 293 raised to 0, since the power is equal to 0, so technically this one is just simply equal to 1. So any number raised to 0 is equal to 1. For 2 raised to negative 8, we will have 1 over 2 raised to positive 8, and 1 over 2 times 2 times 2 times 2 times 2 times 2 times 2 and times 2 will give us 1 over 256. So this one is our final answer here. And for the last one, we have 3 raised to 5. And 3 times 3 times 3 times 3 times 3 will give us 243. So this is our answer for this one. So that's it for exponents. So in the next video, we're going to use our knowledge here in order to come up with the idea on scientific notations. Now let's talk about our next topic, which is the scientific notation. In general, scientific notation is written in the form a times 10 raised to n, where a should be always be greater than 1 but less than 10, and it is being multiplied by any power of 10. So later, we're going to encounter different kinds of scientific notation. So let's have first this table. In this table, we are given the following expression: 7.7 times 10 raised to 0, 7.7 times 10 raised to 1, and so on and so forth. And if you will notice, the power of 10 here are all positive, including 0. So let's have first 7.7 times 10 raised to 0. So it's also the same as 7.7 times, since 10 raised to 0 is equal to 1, so this will become 7.7 times 1. And it will give us 7.7. While 7.7 times 10 raised to 1, this is also the same as 7.7 times 10. And 7.7 times 10 is equal to 77. While for 7.7 times 10 raised to 2 is also the same as 7.7 times 100. And that will give us 770. And for 7.7 times 10 raised to 3, that is also the same as 7.7 times 1000, or simply 7,700. And last one would be 7.7 times 10 raised to 4, or 7.7 times 10,000 will give us 77,000. Now let's try to find out what happened to the values as we multiply it to a power of 10. Now 7.7 is first multiplied to 10 raised to 0, and then multiply it to 10 raised to 1, 10 raised to 2, and so on and so forth. Now try to observe if there is a relationship between the power of 10 to the movement of the decimal point. Now, in the first scenario, 10 is raised to 0. Did we move the decimal point? No. Now, in the second scenario, or in the second case, the power of 10 is 1. And 7.7 became 77. Did the decimal point move? Yes, it was moved to the right. How many times? 1. Now, for the third case, 7.7 times 10 raised to positive 2, it became 770. Now, how did it happen? How many times did the decimal point move? 2 times, and in the right side as well. And for 7.7 times 10 raised to 3, it became 7,700. And if you will notice, the decimal point moved 3 times to the right. 1, 2, 3 to become 7,700. And for the last one, 7.7 times 10 raised to 4, it became 77,000. And in this time, we move the decimal point, or the decimal point moved to the right 4 times. 1, 2, 3, 4. That's why we have 77,000. At this point, what we are going to observe now is what happened to the value as we multiply it to a negative power of 10. And in this example, we have 2 being multiplied to 10 raised to negative 1, 10 raised to negative 2, 10 raised to negative 3, and 10 raised to negative 4. So what we are going to do to get its value is to first convert the powers of 10 into fraction form, and then going to decimal before we multiply it. So let's have first 2 times 10 raised to negative 1. 10 raised to negative 1 is also the same as 1 over 10, as per the discussion that we had a while ago. And 1 over 10 in decimal form is also the same as 0.1. Now 2 times 0.1 will give us 0.2. For the next one, we have 2 times 10 raised to negative 2. 10 raised to negative 2 is the same as 1 over 100. And 1 over 100 in decimal form is also the same as 0.01. And the product of 2 and 0.01 will result to 0.02. For the third one, we have 2 times 10 raised to negative 3. And 10 raised to negative 3 is the same as 1 over 1,000. And in decimal form, it is also the same as 0.001. And multiplying these two, 2 times 0.001 is also equal to 0.002. And lastly, we have 2 times 10 raised to negative 4. 10 raised to negative 4 is also the same as 1 over 10,000. And 1 over 10,000 is also equal to 0.0001. And multiplying these two, this will give us 0.0002. So we have completed the table and we were able to get the value of 2 being multiplied to negative power of 10. Now try to observe again the relationship of the movement of the decimal point after we multiply it to the negative powers of 10. Now in the first one, 10 is raised to negative 1. And from positive 2, it became 0.2. For the second one, 2 times 10 raised to negative 2, 2 became 0.02. For the third one, 2 times 10 raised to negative 3 became 0.002. And 2 times 10 raised to negative 4 became 0.0002. Now try to observe if there is a relationship with the movement of the decimal point to the values that we obtain. Let's have 10 raised to negative 1. From 2 it became 0.2, so the decimal point from here was moved to the left once. From 2 it became 0.02, it was moved twice. Now from 2 it became now 0.002, and that is moved thrice or 3 times. And lastly, from 2 it became 0.0002, it was moved 1, 2, 3, 4. To have this one, it was moved 4 times. So technically, this gives us the idea that whenever a number is being multiplied to a negative power of 10, the decimal point is just being moved to the left depending on the value of your exponent. So if it is negative 1, it will be moved once to the left. And if it is negative 2, it will be moved to the left twice. So the negative indicates that the movement is to the left. In the first two tables that we have observed and discussed a while ago, we have learned how to convert scientific notation into standard form. That if the power of 10 is positive, we are just simply moving the decimal point to the right, and if the power of 10 is negative, we simply move the decimal point to the left. Now, what if we are going to do the other way around? What if we are going to start with the standard form of the number, going to the scientific notation? How are we going to do that? So first things first, always remember the general form of scientific notation, that it should be written in the form a times 10 raised to n, where a should be greater than 1 but less than 10. For the second step, what we're going to do is to locate the decimal point. And after locating your decimal point, identify whether you're going to move it to the left side or to the right side. So how are you going to know that? Always take note of your goal that you need to make it greater than 1 but less than 10. So let's have this example, 7,700. So we wish to make it greater than 1 but less than 10. So we need to move the decimal point, which is located on the rightmost part. We need to move it 1, 2, 3 times to make it 7.7, which is now greater than 1 but less than 10. And that number of movement that we have indicates the exponent of our 10. So we will now have 7.7 times 10 raised to 3. Now the question is, should it be positive or negative? It should be positive because the original number that we have is greater than what we have now in the scientific notation. That from 7.7, it is representing a larger value, which is 7,700. So meaning to say, the exponent of your 10 should be positive to make it larger. So that's the logic behind. Now when we're going to encounter negative exponent of 10, like this example, we have 0.02. We wish to make it in scientific notation. So we need to change it in a form such that your a should be greater than 1 but less than 10. So we need to move the decimal point to the right twice. So if we move it to the right twice, so it will now become 2, which is greater than 1 but less than 10. So we will now have 2 times 10, but what is the power of 10? Take a look back on how many movement did you have to reach 2. So you made 2 movements. So that will become, or that indicates that your power should be 2, but it should be negative or positive. This time it should be negative since your original number is smaller than what you obtained in your scientific notation. That 0.02 is less than 2, and your scientific notation is representing a smaller number. That is why the power or the exponent should be in negative form. So that's it for our discussion about exponents in scientific notation. I hope you learned something from this video. Thank you for watching!